Welcome to the Political Economy of the Environment. This episode is about regulation and environmental protection. Regulations are deployed to try to implement objectives of environmental policy, and those objectives include, perhaps most importantly, safety, keeping the people safe from unreasonable health hazards, keeping the environment safe, efficiency, trying to make sure that high costs are not being inflicted on society relative to relatively modest benefits. Sustainability, trying to protect the well-being of future generations so they're no worse off than we are today. And justice, trying to make sure that environmental harms aren't disproportionately inflicted on certain communities just because they are racial or ethnic minorities or low-income people. Broadly speaking, there are two types of environmental policies. One of them is what's called regulation. Those are rules and standards. Those basically involve rules that tell us what we should do or shouldn't do. Those are the most conventional type of environmental policies, and those are the ones we're going to be talking about today. They're sometimes called by people who aren't that enthusiastic about them command and control regulations, a phrase that recalls command and control economy, which was what was the description for the economy of the erstwhile Soviet Union. But there are rules and regulations, and the reality is we got lots of rules and regulations in our lives. Whether you think you got too many or too few is a matter on which reasonable people might be able to disagree. Today, we're going to be talking mainly about that type of environmental policy. But there is a second type that we'll talk about in another video, which are incentive-based policies, like pollution taxes or cap and permit systems that don't tell people what they have to do. They don't tell them you have to install this pollution control equipment or meet this emission standard or whatever. They just say, hey, if you're going to degrade the environment, if you're going to emit pollution, for example, you're going to have to pay. And here's how much you're going to have to pay. And you decide how much pollution, for example, you're going to emit. So let's think about that first category, regulation. Here's some examples. Mandated technologies, source-based emission standards, ambient concentration standards. Ambient means in the environment around us, like in the water that you drink, and mandated disclosure of environmental information. When the Clean Air Act came into force in the 1970s and the EPA started to regulate pollution from automobiles, amongst other sources, it mandated that new cars sold in the United States all had to have catalytic converters to reduce air pollution. Second kind of regulation are source-based standards, where you measure the level of pollution coming out of a given source, like the tailpipe of an automobile, and you say, hey, if your pollution's over this standard, you're breaking the law. You're violating the rules. So in most states, you have to go in every year to get an auto inspection, and one of the things they do in that auto inspection is they measure the amount of pollution coming out of your tailpipe. Used to be they'd stick a hose on your tailpipe. Nowadays they can get a lot of that information just by looking at computer devices that are installed with the engine of your car. And if you fail that emission test, you got to get it fixed. You can't drive your car if you're emitting too much pollution. That's a source-based standard. It's a type of rule, a type of regulation. Ambient concentration standards, a good example of those are standards for water quality. So around the country, water supply systems, public water supply systems, have to test their water. And if levels of certain chemicals surpass the allowed thresholds, surpass those ambient concentration standards, they have to shut down the water supply system or do something to lower the levels, the concentrations of those chemicals. That's another kind of regulation. A fourth kind of regulation is mandated disclosure, the right to know. An example of that is that in the United States, after the Bhopal chemical disaster in Bhopal, India, Congress passed the Emergency Planning and Community Right to Know Act in 1986 that created something called the Toxics Release Inventory. That act mandates that industrial facilities across the country who meet certain reporting threshold criteria are required every year to report their releases of hundreds of different toxic chemicals into our air, our land, and our water. And that information is collated by the Environmental Protection Agency and released to the public. And the idea is that the public has the right to know what's in our air, what's in our water, and who put it there. That's another type of regulation, a regulation that requires people to release information. What happens when people have that information? It can provide a basis for formal regulation, right? It can provide a basis for other kinds of policies designed to deal with the pollution that we now know by virtue of mandated disclosure is going on. And it can lead to what's called informal regulation, public pressure, pressure from the media, pressure that doesn't necessarily involve changing the rules, but it just involves what happens when the only thing that's changed is people know what's in their environment and who's put it there. And in fact, there's a lot of evidence that once the toxics release inventory started coming out in the late 1980s, firms, polluters actually changed their behavior. They didn't want to be seen as bad actors in their communities. And once they knew that the people knew what they were emitting, they often cleaned up their act. So those are the traditional types of regulation. What are some of the attractions of regulation as a way to address environmental problems? Well, they include the following. First, that regulations may be relatively easy to administer, relatively easy to enforce. You ask, is a person or a firm, are they breaking the law or not? Does your automobile pass that annual emissions test or doesn't? Does the smokestack in the power plant have a scrubber to remove hazardous pollution from its effluent gases? Or doesn't it? Is the scrubber being cleaned and maintained or isn't it? These are things that are relatively easy to understand, relatively easy to enforce. Secondly, and this actually is the same point really in different terms, regulations are straightforward. When you set the rules of the game, people can understand, okay, this is good, this is bad, and I know what I have to do. And related to that too is a third attraction of regulations, which is the basic notion that the environment's not for sale. We're talking here about what's right and what's wrong. Here are the rules. You play by the rules or you don't play by the rules. Whereas incentive-based systems, where you have people pay to pollute, some people think that gives a message that it's really okay to pollute as long as you pay for it. It gives the message that the environment is for sale, maybe for sale to the highest bidder. So there are folks who prefer regulation for all these reasons, because it's simple, straightforward, not very costly to administer, and it doesn't convey the message that the environment's for sale. What about the drawbacks? What are some of the problems encountered with regulation? Well, let me mention a few. One is that there's a problem of how you set the regulations, how you decide what the rules are going to be. There's a lot of scope for lobbying, a lot of scope for bureaucratic discretion in deciding on those rules. I'll talk more about that in a sec. Another problem is that the appropriate regulations may vary across locations, vary over time. It may not be that there's a one-size-fits-all set of rules that's the optimal rule for every place. It may be that certain places, for example, that are more polluted than other places ought to have tougher regulations than the places that are relatively clean. And thirdly, it may be that the costs of what is called abatement, the costs of reducing environmental harm, the costs of reducing pollution, for example, the costs of complying with environmental regulations may vary amongst firms, may vary across polluters. And if regulations use a one-size-fits-all approach where everybody's got to do the same thing, you're going to have a situation in which some firms are paying more to clean up the environment for the same environmental cleanup than other firms because it's more expensive for them to comply with the regulations. And it may be, and this is a point that economists make, that society could achieve the same total environmental quality benefit by reallocating the cleanup to those who can do it more cheaply. So that's a point we'll get back to in a video on incentive-based policies. What I want to drill down on a little bit now are some of those problems associated with the regulatory process itself. Setting the requirements involves dealing with a lot of uncertainty, a lot of incomplete information. We often don't really know about all the hazards associated with various kinds of environmental changes, like emitting chemicals into our air, land, and water. And because we don't know, there's scope for reasonable people to come to different conclusions about what ought to be done. Moreover, there are interests and incentives that might lead people who even have the same information to come to different conclusions because it's in their interest to either want more environmental regulation or want less. And furthermore, at each stage of the regulatory process, there's active contestation, active disagreement between the proponents and opponents of the regulation. And you see that in the initial hearings where environmental laws are proposed. You see that in the drafting of the environmental legislation itself. You see it in the agencies that translate those legislative objectives into regulations. You see it in the enforcement of the regulations once they've been drafted and implemented. As Abraham Lincoln is reputed to have once said, a law without enforcement is only good advice. Just because you have a rule doesn't mean everybody's going to follow it. And the degree of enforcement is something that requires resources and is, again, contested. There's also some room for contestation even when the laws are being enforced in determining whether someone's really guilty of violating the law or not. If you're going to go to court, you've got a whole set of regulatory implementation processes that happen there. And then once a person or a firm is convicted of violating the law, you've got the question of, well, what the penalties are going to be. And often there's some discretion in the judiciary to assess those penalties. So at each stage of the regulatory process, from the very hearings about whether we should have laws to translating those into actual outcomes of court decisions, there's contestation along the way. Let's think a little bit more about one piece of that puzzle, which is the imperfect information problem. What do we know? What's the basis for setting environmental policy? Well, this warning sign, which you have maybe encountered on some products, is a label that's put on to comply with California law. And the reason you see it, the reason you see, hey, this is known in the state of California to cause cancer, birth defects, or other reproductive harm in this particular label, right, is because California thinks it knows more. The regulators in California think they know more, have been able to make regulations on the basis of what they know more easily than federal regulators in some cases. So there are products, there are chemicals that are known in California to cause harm, but that aren't yet regulated nationwide. And so you get this label on the products. What's known and not known? It's a matter for debate. And when the information is imperfect, one of the real questions is what threshold level of evidence do you have to have before you can regulate? And again, that's something that reasonable people might disagree on. Another big question when you've got imperfect information is who should have the burden of proof? Say we're talking about introducing a new chemical into the environment. Should the burden of proof be on the party introducing that chemical? The firm, if we're talking about a manufacturing firm, for example, discharging something into the river? Should it be the burden of proof be on the firm to determine that this stuff is safe? Should they not be allowed to dump it into the water until they prove it's safe? Or should the burden of proof be on the regulators, on the government agencies, to prove that it's hazardous before they can regulate it? Where should the burden of proof lie? Should the chemical be innocent until proven guilty, or guilty until proven innocent? Who should pay the cost of doing the research to determine whether this stuff is safe or hazardous? These are big questions, and the way one answers those questions can vary between countries, and even within a single country, it can vary. It varies here in the United States, because when we come to regulating food and drugs, food additives, food preservatives, food colorings, pharmaceutical products, the regulatory agency is the Food and Drug Administration, the FDA. And the burden of proof lies on the firms introducing the new food additive or the new pharmaceutical product. They have to do the tests, they have to fund the tests to determine whether this stuff is safe or not, or in the case of pharmaceuticals, whether the benefits of the pharmaceutical outweigh any adverse side effects. And the FDA then looks at the evidence that's submitted to them and weighs it up and makes a determination as to whether we're going to allow this stuff to be introduced into our food supply or into our pharmaceutical product mix or not. That's one way to assign the burden of proof. But when it comes to clean air and clean water, We've assigned it the opposite way. The EPA, if it wants to regulate what's in your air or in your drinking water, it has to prove the stuff is hazardous. It has to come up with the evidence. It has to do the research. And once it shows that the stuff is dangerous, then and only then can it regulate it. Of course, again, information is always imperfect, so proving to someone's satisfaction that something is hazardous or something is safe is always open to correction later on when new information emerges. But some information is certainly a lot better basis for making a decision than no information. And the question here is, how do we get more information? Whose responsibility is that? What do we do in the meantime? Thinking about that EPA procedure, putting the burden of proof on the regulator, what's it mean in practice? It means that there are a lot of chemicals out there that aren't regulated. We don't know, or at least the EPA hasn't to establish that we know beyond any doubt that would prevent regulation, whether certain things are hazardous or not. So if you look at ambient water control standards, for example, the way those are implemented is through something called MCLs, maximum contamination levels. And if you look at the national drinking water standards, you can get this online. You can go on the web and see it. You can see all the chemicals for which the U.S. Environmental Protection Agency has established MCLs. They've got MCLs for arsenic, for example. There's a certain level of arsenic in drinking water. If the level gets beyond that, they have to shut down the water supply system. It's considered unsafe because it's surpassed this regulatory threshold, the maximum contamination level. And the interesting thing to think about is how many chemicals have MCLs established for them by the EPA. This is, over the last 40 plus years since EPA began issuing maximum contamination levels to protect water quality in the United States. And the answer is, it's fewer than 100 chemicals. Fewer than 100 chemicals in the United States have MCLs established for them by the EPA. There are thousands of different chemicals that are out there in our water bodies. Some of them are in our drinking water, hundreds in your drinking water, depending on where you live. And yet, fewer than 100 of them are regulated. And why is that? Is it because all the other ones are safe? No, it's because we don't know yet whether other ones are safe or not. It hasn't been proven that they're hazardous. And the basis for regulation by EPA is it's innocent until proven guilty. One way to describe the difference between those two methods of assigning the burden of proof when we've got imperfect information, the method used by the FDA and the method used by the EPA, is to talk about the precautionary principle. The precautionary principle is the idea that when there are threats of harm to the environment or to health, we should take action even if we don't fully understand all of the cause and effect relationships, even if the science is not yet 100% definitive. We can think of the FDA approach as being more precautionary than the EPA approach, in that the idea is that you prevent things from being introduced in the environment until you've proven that they're safe. In other words, you look before you leap. You take a precautionary stance. That general philosophy has been implemented with respect to air and water quality as well in the European Union. A decade ago, back in 2006, the European Union passed legislation called Registration, Evaluation, and Authorization of Chemicals, or REACH for short. That was the acronym. It entered into force in January 2007. And it applies to all firms operating in Europe, no matter where they're owned. If they're going to operate in Europe, they have to comply with the REACH legislation. And what the legislation requires is that they test the various chemicals that they're releasing into the environment to establish whether they're safe or not. It gives them basically a decade, or gave them about a decade, to complete those tests. But the idea was, if the tests showed that these chemicals were hazardous or failed to show that they were safe, they'd have to be removed. Europe wouldn't allow those chemicals to be dumped into their air and water. The European Commission of the EU estimated that the cost to industry of implementing REACH would be about $3 billion over the 11-year phase-in of the period. and that the benefits to Europe would include $65 billion in saved health costs over the first 30 years of the policy. In other words, they reckon this was a really efficient thing to do, to require firms to undertake these costs. The firms weren't happy about it. The International Herald Tribune reported that this legislation, when it was being debated, unleashed the biggest lobbying efforts by U.S. corporations ever undertaken in Brussels, where the EU headquarters is located. But the legislation passed. The firms are complying with it. So far as we know, it hasn't bankrupted the European economy. And the result is that in Europe, you have environmental regulation taking place using that same precautionary approach that we in the United States apply to food and drugs. Maybe this is a case where the European example will be one that one day we decide to follow here as well. Thanks very much.